Hi everyone, you're welcome once again to another section of Science and Mathematics with Anderson. On today's section of Science and Mathematics with Anderson, we're going to be looking at mathematics as a subject. And today in mathematics, I have a lot of messages on my WhatsApp from most of my students who have asked me that I should please treat circle geometry. So I thought it twice that since I have a lot of students that are asking me to treat circle geometry, why don't I share this on my YouTube channel for those of you out there who are struggling with this topic known as circle geometry in mathematics. Now, before I continue, I would plead with you to click the subscription button below. Click the subscription button below so as to subscribe to my YouTube channel and get notified whenever I post a new video on my channel. And please don't forget to like and share my YouTube videos with your friends, your colleagues, your playmates out there who are struggling with sciences and mathematics. And if you're a parent out there or you're a guardian that has a child or someone who is about to write the WAEC based examination or the NECO based examination and they are struggling with mathematics and then they're also struggling with physics, chemistry, as the case may be, please, this YouTube channel is meant for you. It is meant for you. And I'll also plead with you that if there are topics that you're finding it difficult to comprehend or understand, please, you can actually write it there on the comment section, or you can send it to me via WhatsApp, and I would do well to treat that topic with you here on my channel. But please don't forget to subscribe to my YouTube channel, share and like my videos. Now, we're going to move on to this topic known as circle geometry. So today on circle geometry, we're going to be looking at the part 1 of circle geometry. The part 1 of circle geometry. Sorry, let me write this bold so that you can actually see it. We're going to look at the theorem that revolves or hovers on the center of the circle. We're going to look at the theorem that has to do with the center of the circle. Now, there are a lot of theorems that has to do with the center of the circle, but we're going to look at one on this particular episode. So this is the first episode of what? Circle geometry. So like I said, I would not want to mumble jungle everything. I want to break everything into pieces so that you'll be able to understand, because when you understand this topic in pieces, it will be easier for you to bring those pieces together to solve complex questions. Like I always said on my YouTube channel, we're always going to start from simple, then we'll move on to complex. We're not going to start from complex downward. We're going to start from simple so that everybody can have the adequate basic fundamentals involved in this topic, and then we'll build up to complex questions. Look at questions from the WAEC past questions and the JAM based past question. Now, at the center, this is the center of my circle. I have a line from here to here. Now, any line that connects from the center of the circle touching the body of this circle is actually called your radius, and they are actually equal. They are equal sides. But that's not what we're going to be considering today. What we're looking at is a figure like this. So this is A, this is B, this is C, and this is O. This is O here. Okay, now if you look at this here, this is the center of my circle, and I have my theta here. My theta is at angle A. Now, most of the times, this is what they do in this topic. in circle geometry alongside plane geometry too. So when you have like this is called triangle BAC. Now, the angle being referred to here is always the center alphabet. The angle being referred to here is always the what? The center alphabet. So, in this angle or triangle BAC, I'm referring to angle A. My angle A here is my theta. My angle A there is my theta. Now, one thing I need you all to also know is that whenever you have two lines touching the body of your circle, it is known as circumference. Whenever you have two lines touching the body of your circle, it is known as the circumference. So this is a circumference, this is a circumference, and this also is a what? Is a circumference. Now, what does it tell us, or what does it say? The theorem states that angle at the center is twice the angle at the circumference. Angle at the center is twice the angle at the circumference. So let's write that down. Angle at the center equal to twice the angle at the circumference. Equals to twice the angle at the what? Circumference. So that means that what? That we have here angle BOC. Remember that I said the middle alphabet is the angle we're looking for. And angle BOC, that means O is at the center. That simply means that angle BOC is 2 times angle BAC. 2 times angle BAC, which implies that angle BOC, which is angle O, is 2 times theta, or 2 theta. 2 theta. Now, in the reverse manner, if I was given the angle at the center and I was asked to find the angle at the circumference, now your guess is good as mine. It simply means that the angle at the what? At the circumference will be half the angle at the center. It means that the angle at the circumference will be half the angle at the what? At the center. Don't forget that. It means that the angle at the circumference will be what? Half the angle at the what? At the center. It's very, very, very important. So we're going to look at an example here. We'll look at an example here. So let's say I have a question like this. Now, from this particular point, or at this particular point, please, you should know that though we've not come to that theorem, but when we come there, I will discuss that with you. But I just want you to know that angle I just want you to know that A, B, C, and D, or A, B, D, C, is known as cyclic quadrilateral. A, B, D, C is known as cyclic quadrilateral. So when you have something that looks like a square or a circle touching the circumference of your circle, they are called cyclic quadrilateral. But that is not the theorem that we're going to be looking at today. So we have a question here. If angle BOC is equals to 128 degree, find angle BAC. If angle BOC is equals to 120 degree, find angle BAC. In order to get angle BAC, what we need to look at is what angle are we looking, which of the alphabet are we looking at. I did tell you that the alphabet at the middle is the angle that we are looking for. And it happens to be that where we are looking for what? Angle A in this, amongst this alphabet. Angle A. And angle A happens to be what? Angle at the circumference. Angle A happens to be the angle at the what? At the circumference. Why is it the angle at the circumference? You can see, like I said, when two lines touches the body of a circle, it gives you what? Angle at a what? Circumference. And what did we say? We said that in the theorem that angle at the center of a circle is twice the angle at the what? Circumference. So for this reason, it means that our angle at the circumference, which is angle A, is going to be half the angle at the center. Half the angle at the what? At the center. So that means that angle BAC, sometimes they could write it this way, or sometimes it could be written like this. Either this way or this way. So they could write it in any form for you. So that means half means 1/2 times what? The angle at the center is what? 128 degree. And that will give me 128 divided by 2. 2 in 12 will give me 6, and 2 in 8 will give me 4. That means the angle at the circumference, or angle of A, is simply 64 degree. Simply 64 degree. So please, if you do enjoy my video, don't forget to click the subscription button, like and share to your friends till I come your way on the next episode of Circle Geometry. I remain your humble Anderson Ikechukwu Nathaniel.